Good morning and good afternoon, everyone. This is Jean-Daniel Hostel, the president of the Java Card Forum, and it's my pleasure to welcome you to this fifth seminar in our 2022 webinar series. Today's topic is a presentation from Guido Abate of ST Microelectronics on the new Secured Application for Mobile, or SAM, standard from the GSMA. Guido is Secure Mobile Standards Manager at ST Microelectronics, as well as the GSMA eSIM or Embedded SIM Working Group 3 Chairman for 3 terms now. Prior to being Secure Mobile Standard Manager, Guido was leading the cards product marketing team in the Secure Microcontroller division at ST Microelectronics. And even before joining ST, Guido had various positions in Gemalto technical marketing and in card research and development. This year is the 25th anniversary of the Java Card Forum, and Java Card is a pervasive technology with shipment over 6 billion units in different segments such as payment, identity, authentication, and today especially telecommunications. Modern smartphones now have mostly embedded SIM soldered inside instead of removable SIM, with the subscription profile managed with the GSMA RSP specification. As embedded SIM are now so common, the GSMA started a new specification to share the embedded SIM with third-party application. This specification is the Secure Application Mobile, or SAM. Guido will show you the benefit of SAM in the next presentation, and of course of Java Card. And you will be able to ask questions at the end of the webinar. The microphone will be closed during the presentation. And if you wish, you already also have a chat box where you can post your questions as the presentation goes along. The presentation is recorded, and you will receive also a copy of the presentation by mail, so you can really enjoy and focus, and no need to take too many notes or screenshots. And without any delay, Guido, the screen is yours.
Thank you very much, Jean-Daniel, and thank you for your kind introduction, and thank you everyone to attend this webinar. So today, as anticipated, we will have some highlights and discussion on GSMA SAM. SAM is an acronym that stands for Secured Applications for Mobile, and it is a new standard technology defined by GSMA to empower the next generation of convergence products. Just one note on this naming, convergence products. This is not really a formally defined term, but it is rather a term commonly used, especially in the silicon industry, to identify eUICC that also support the functions of an embedded secure element. So one hardware, two function, embedded UICC and embedded secure element. And thank you for the introduction, especially focusing on the embedded UICC, because this is a concept that we will see quite often during this presentation. So let's see what is the outline of the chat we will have today. First of all, we will start with a quick recap on the eUICC technology, because actually SAM is built on top of the eUICC. And we will see why we define SAM to have the eUICC also support embedded secure element functions, because actually the eUICC is already a secure element by itself. We will go through the technology, not in deep technical details, but just at a high level. We will have a quick view of how Java Card is instrumental for the SAM technology. And at this point, we will have a quite good highlight of what technology does, why it was built, and what are the advantages of it. But at that point, it will be interesting to discuss also about additional developments that are specified as optional in the SAM technology, because they increase a lot the flexibility of this solution, especially for future implementation. This will be discussed just before the conclusion of this presentation. Okay, so let's go. So let's make just a quick recap of what an eUICC is essentially is. I will not go beyond that. So actually, SAM is this technology that sits on top of consumer eUICC. The eUICC is, in 2 words, a SIM, but a SIM that has some additional functionalities. So it's a special kind of SIM, a SIM that is able to host more than one telecom profile. One of them is visible from the device. This is what was specified in the eUICC version 2. In eUICC version 3, actually an eUICC could also have more than one profile enabled at any time. That means there is one physical hardware that is able to support dual SIM, dual standby use cases for a device. Okay, but this is something that maybe we will discuss in 10 slides from now. So this is actually eUICC, a SIM in which the user can switch between the profiles. Now, SAM is a technology that allows to implement the eUICC and secure element functionalities on the same physical components, as anticipated. Now, let's keep one thing in mind that is important. The GSMA eSIM specifications allow to download applets in the eUICC. This is possible, but actually they specify only one way. We can download applets in an eUICC only when these applets are part of a telecom profile. There is no other standard way defined in the eSIM specification to download applets in an eUICC, only as part of a telecom profile. So let's keep this in mind, and we will see in a moment why this can be a limitation. So we remember that the eUICC specification was has different flavors. The consumer one started in 2015, more or less, and is now at version 3.0, so it is quite stable and mature. During the discussion in GSMA, there came up some interesting use cases that then became part of the SAM specification. There are a number of use cases, but let me point out to 2 specifically, because they are at the heart of why SAM was developed. The first use case is, let's consider a user with a device. This device has a eUICC, and this user has a telecom profile, and at the same time is also supporting, and is also the user of some bank app. There are cases in which the bank and the telecom operator providers are either the same company or belong to the same shareholder. This is a case in which it is important that the two things, so the telecom profile and the bank account, are separate, are managed separately. a user of the bank account may want, likely he wants to keep the bank, even if, for example, he changes the telecom operator. So that's a problem if the bank account application is delivered together with the telecom profile. Let's consider the second use case that is more driven by e-government applications, especially in Europe, but not only, but especially in Europe. There are some new ID use cases. I'm referring here specifically to mobile ID use cases that are promoted in some European countries. And in these cases, there are countries that prescribe that the e-government root of trust shall be managed or at least authorized by the relevant government. This is something that is clashing definitely with the PKI model that is specified by the eSIM specification. Because in the eSIM specification, we have that there exists a PKI architecture with a root of trust that is global, defined by GSMA or in following versions also by other entities, but anyway, it is global. In these e-government use cases, we are talking about root of trust that are local, I mean, national or even more local to specific organizations, set of municipalities or things like that. So this is something that has also to be carefully considered. So the root of trust has to be for these kind of applications have to be separate from the root of trust that is used by the eSIM ecosystem. Now, SAM considers a lot of other use cases. The full list is in the SAM.01 version 1.0 document that is available on the GSMA website. It's public. Here you can have the reference, and it is a nice and quick reading of why SAM was developed, what is the full list of use cases that has been considered. But anyway, these two give quite an important highlight of what are the use cases that had to be addressed. Now, why those use cases cannot be addressed by the eUICC as it is, without any add-on? Well, fundamentally for two limits. The first one is since applets are can be deployed in the eSIM specification only through telecom profiles. Well, I'm sorry. We have to consider a model like this one. Let's take a look at the figure at the left of this slide. We have a device. In the device, we have a device app. It may be, I don't know, a banking app, for example. The eUICC is in the device, of course. In the eUICC, there are two profiles, and the banking applet that communicates with the device app is in the profile 1. Profile 1 is enabled. This means, according to the eSIM specification, that the eUICC behaves as a SIM in which there is the file system 1, the applet 1, all of this is visible to the world that is external to the eUICC, so the device app can communicate with these applets. The other profile, profile 2, in this moment is disabled, so it is invisible to the device. So the device doesn't know at all that this profile exists. everything is working plainly in this device and eUICC configuration. So the applet is visible to the device app and available to the end user. But what happens if the user moves, for example, abroad? He is, I don't know, a French user moving to to Brazil, and he changes the profile because he needs a Brazilian telecom operator to communicate with because he wants to save on roaming. So he disables the profile 1 and enables profile 2. We are in the condition that is explained in the figure on the right. So the profile 1 is disabled. It means, of course, that the telecom profile is not anymore accessible, but unfortunately, the applet is part of this telecom profile, and the applet, that is a banking applet, becomes unreachable from the device app. The device app will not find it anymore. So the service, the banking service, in the end, will be unavailable to the end user. So that's the first shortcoming for that we see for a pure eUICC implementation in which the applet can be delivered only in telecom profiles. That's why we have use case 1. How to overcome this shortcoming? Well, actually, this is what SAM does. The Convergence product, so the eUICC plus secure element, is not only able to host profiles, but also able to host application service provider security domains and that are separate from the telecom part. So when we have this kind of situation, and when with SAM we are able to download applets in a new ASP security domain, we are able to disassociate the telecom profile state from the state of the application service provider applet. It means, let's see what happens if in this situation we have profile 1 and profile 2. The first one is enabled and the second one is disabled. Well, the applet is visible because it is in another security domain dedicated to that. We switch profile, so we enable profile 2. Perfect. So we don't have any effect on the ASP security domain. So the user enjoys the service, whatever is the telecom profile enabled. That's what essentially SAM allows. Then let's go to the second use case. So actually, SAM allows to download applets. I'm simplifying a bit, but let's say able to download applets in separate security domains on eUICC. You see here in the figure on the left of this slide a general SAM architecture. I will not at all go into the details of this architecture. I just want to show one thing, that there is one CI that acts as the root of trust for the SAM ecosystem. And actually, this CI is separate from the GSMA CI. So the two ecosystems, SAM and eSIM ecosystem, are separate. And we don't have any restriction on what the SAM CI can be. It can be authorized by government, it can be authorized by other authorities, so whatever. But the point is that with this kind of architecture, we are able also to support, for example, the mobile EID use cases like the one that was explained before. So in this case, each SAM applet chains up to a root CA that is domain specific. One thing I want to say is that the GSMA ecosystem is conceived to be a certified ecosystem. I mean, the entities that join the GSMA eSIM ecosystem, the eUICCs, the servers, etc., have to undergo some kind of certification. And everything is fully specified in the eSIM specification since version 2. For the SAM, it is envisaged it will be the same, but for the moment, the functional and security certifications are not yet discussed. They will be, but not yet. Okay, so we are giving here just a quick highlight of why SAM was developed and what are the limitations that had to be overcome. But now, how important is Java card for SAM? Well, I cannot say less than it is essential, it is instrumental to develop SAM on top of a eUICC, because the application service provider services can be administered in an interoperable way only if they are implemented through Java card applets. So for the moment, there is no other technology that allows to have this administration in an interoperable way. This is the first reason. But the second reason is that actually you see that the whole SAM concept is about segregation of services. So we have services that are provided by different service providers, and they have not to interfere with each other, of course, and they have not to interfere with the eSIM application. So clearly, the applet segregation provided by Java card is instrumental when dealing with services provided by different service providers in the same physical chip. So we need to have a lot of security features and to enable this segregation, and Java card is quite important into ensuring that. Quite quickly, we are talking about SAM. It's not only GSMA working on SAM. GSMA had quite an important role in starting the job, in defining the architecture, the requirements, and starting with the technical solution. But the technical specification is actually defined together with the GlobalPlatform. As of today, we have that the requirement and architecture, the one that was shown a few slides ago, are approved and published. They are public, so there is no restriction. You can go on www.gsma.com and make a search for SAM.01. So that's published. SAM.02 is not yet published. It's still ongoing. So there is still work to be done before delivering this technical specification. That, as said, is done together with GlobalPlatform, because some technical enablers are defined there. More specifically, GlobalPlatform defines the document some configuration for eUICCs version 0.0.0.11. Now we are at this version, and this is currently under committee review. This document is fundamentally an extension to eUICC configuration that adds SE configuration requirements. So it's it's simply defining something specific for the eUICC that implements SAM. So this is for the technical part. Essentially, GSMA and GlobalPlatform are working more on the technical side, on technical specification. But there are other bodies that are also working on SAM, namely TCA, the Trusted Connectivity Alliance, and Eurosmart. TCA drafted a position paper on SAM. It's called Secured Applications for Mobile TCA Position Paper. This position paper is actually in its final draft stage, and it will be okay. It is actually under the TCA approval and publication process. So supposedly we will see this paper in hopefully a few weeks. Not sure, but the plan is to have it really in a short time on the TCA website. And second, we have a white paper by Eurosmart done a while ago, actually more than a year ago, but it is quite interesting. It offers a different perspective on SAM, and its name is GSMA SAM Solution: Opportunities and Challenges for Mobile Identity. And here there is the reference. It's of course it is a public document. You can download it. It's quite interesting because it offers a perspective of how SAM can fruitfully used from the angle of mobile ID in the European Union. What are the opportunities? What are possibly the shortcomings? What are, but especially the opportunities, I'd say. So Eurosmart is giving quite very good and exhaustive view on what are the benefits of SAM when used in the mobile ID use cases. Additionally, Eurosmart also cooperated with and is cooperating with GSMA to review the requirements, and actually this review had a lot of influence on the new version of SAM.01 document. All right, so this is the quite a highlight of what SAM does and why it was built on top of an eUICC to allow use cases like the embedded secure element on top of the eUICC. So I hope it is clear what was missing and what SAM is adding to an eUICC implementation. But once this was done, it was realized that an eUICC implementing SAM may offer additional services and can be even more flexible to offer these services. So the SAM.02 document, that unfortunately is still in draft stage, offers additional ways to implement SAM. To show this, let me talk about different architectures that we may have in a device in which there is an eUICC that is also an embedded secure element and supports SAM. let's imagine that we have a device in which the eUICC plus secure element is connected to the device only through the ISO interface. We know that if the eUICC is an eUICC version 3, this eUICC may support multiple enabled profile. So it means more than one profile can be enabled at the same time, and the device can work as a dual SIM, dual standby device, but in which the SIM is only one. There is only one physical eUICC, and not two SIM like it used to be in past times. So the ISO interface performs a multiplexing between the profiles, and this multiplexing is defined, is standardized by EUICC via the MLI specification, multiple logical interfaces. So as said, there is a EUICC specification about that. It's already approved, so I will not say a lot about it. But what is interesting is that this architecture and this technical solution, MLI over ISO, can be used also to perform multiplexing with the ASP security domains. So with services that are not in the eUICC part, let's say, of this convergence products, but on services that are on the SAM part of this product. So this solution exploits the concept of MLI via ISO and the concept of logical secure element that is also defined in EUICC. So we have different logical secure element when we have one physical hardware and separate domains that each of them can act as, can be seen by the device as a secure element, but it's not physical. Is simply logical, and MLI can be used to switch between the different logical secure elements. So this adds a lot of flexibility here on the eUICC plus embedded secure element implementation. This is one of the possible architecture when we have a convergence product that is only connected to the device through ISO. This is one case, but this is not the only case. Actually, it is easier to see a situation like this one. When we have not one single interface that is ISO to connect the eUICC with the device, but when we have more than one physical interface to connect the eUICC plus the device. Let us remember that actually we come from a situation in which the eUICC and the embedded secure elements typically were separate. So each of them had its own connection with the device. And this is an architecture that is bridging the former situation quite naturally. So we have ISO to connect the baseband with the eUICC logical secure elements. And we have other kinds of interfaces, physical interfaces, that connect maybe the application processor with other logical secure elements. And these physical interfaces may be, well, they can be whatever. Here I just name some example: I2C, I3C, SPI, whatever other that can be used. Now, so what are the additional flexibility we could consider here, and that could be considered also for future developments by other bodies like JavaCard Forum? Well, just to make an example, let's consider the case in which the communication between the device and some logical secure elements, so the SAM part, occurs through I3C. This is quite, this is something that is quite interesting, because actually we could leverage the benefit to use native features of I3C to address the virtual targets. So I3C defines, in fact, natively what they are called virtual targets. So logical targets that are stored on the same physical component. So actually, we don't need to define a new multiplexing between on a physical interface here when we have I3C. I3C already supports that. I3C already have a dynamic addressing of the targets. And on top of that, a target may be a virtual target. So several targets can be hosted in the same hardware. So as long as we use I3C for this communication, the effort to specify a new multiplexing between the device and the embedded secure element is not necessary. But this is not the only advantage we may have when using I3C. Let's consider, for example, something like that. The eUICC and the various SAM security domains may be implemented as SSP bundles. So these eUICC plus embedded secure element may be implemented as a eSSP. This is a specification that is also done by ETSI. Bundles are essentially like new operating systems that can be downloaded and activated on a secure element. And in this case, on eUICC plus embedded secure element. We have to consider that since the bundles can be downloaded and activated, because this is what is defined in the SSP specification, this kind of secure element of eUICC plus embedded secure element becomes extremely flexible, and especially when it is used in conjunction with I3C. Because one new bundle, let us consider, for example, that we download here bundle number 4, that is not existing at this point in this figure. If we download bundle number 4, bundle number 4 will have assigned, once it is downloaded, and a dynamic address on the I3C bus. And I3C also supports a feature that is called hot join. It's a sort of plug and play. A new bundle becomes visible in the moment in which it is downloaded, after download and installation. The I3C is able to immediately see that. So this is extremely powerful as a feature, once more, if in the case in which I3C is used. So this is also one possibility. Of course, it is an optional possibility that is envisaged by the SAM specification. So again, what are the potential developments for Java card, considering these additional architecture options? Well, some new physical interfaces like I3C could be potentially considered by Java Card Forum in the scope of SAM as explained. Just to summarize, I3C specifically allows for further potential extensions because MIPI I3C, as said, defines the concept of virtual target that can be mapped onto the concept of virtual secure element defined by ETSI. So the concepts are different, defined by different SDOs, but actually can be mapped on each other. And then there is the point that new virtual secure elements can be dynamically downloaded in the field and immediately be accessible on the I3C bus thanks to the hot join feature that again is one of the essential enablers defined in the MIPI I3C specification. Let me go to the conclusion. So Java card, as said in the first part, is a fundamental building block for some implementations, for the reasons that were explained earlier, for the interoperability and segregation between services that it provides. And then new use cases and new architecture, potential architecture, open opportunities to design Java card extensions and fulfill new user scenarios. And it's all for me for now. So thank you very much for your attention. So, Jean-Daniel.
Thank you very much, Guido, for this presentation. We will be opening the microphone for questions. In the meantime, I have one myself, which is in the smartphone, the modern one today. You have both the the embedded SIM and the embedded secure element. How do you see the split of secure applications deployment? Will there be like a tendency to go on the embedded SIM or the embedded secure element? What will be the I would say the drivers between the balance of the two?
Well, actually, it is really use case driven. Every time we will have cases in which the services will have to be provided through a telecom operator. In that case, it makes full sense that the applets, the Java card applets, will be in the telecom profile. So a pure eUICC technical specification is more than sufficient for that. But every time that we need to download services that are not directly, how to say, conveyed through telecom operators, well, in that case, it makes full sense to rely on some architecture, and especially on the PKI architecture that is provided by SAM. Because actually that is the most constrained point to be considered. So deployments may have to go through different approvals. I don't know, mobile EID in Italy or in another country may not necessarily, well, almost certainly would not go through the GSMA CI. So in that case, we need to have something specifically.
So what says it's on a case-by-case basis, whether, for example, a mobile identity applet would use the embedded secure element or the embedded SIM.
Yeah, exactly.
And also the one you shown with the bundle, you know, where you download the different bundles in the embed the SIM. Yeah, I'm not familiar about the SSP too much specification, but you don't overwrite the telecom application when you download the bundles. There would be on a separate space.
Yeah, absolutely. So you can download separate bundles on the same physical hardware, and the bundle coexists. So you can activate one of them. One of them can be active at any one time, but the others are not overridden. So they keep existing. So that, okay, in 2 words, the concept is I have to use the telecom bundle to connect with my operator. At one point, I need to manage, I don't know, a bank transaction. So the device has to activate the banking bundle. The banking bundle becomes the one that takes the input data, resolves the transaction, gives the answer, and then the device can reactivate the telecom bundle. So they all are at the same time on the convergence product.
Okay. There's no, I mean, problems with if, for example, the telecom bundle is deactivated to have mobile ID bundle to do some kind of mobile features, then you would be still able to receive the calls or that
Yeah, absolutely.
Okay. We have a question from Stefan. Stefan, I don't know if you want to ask directly, or should I read the question? The question from Stefan is, what is the deployment time frame of I3C from your point of view?
Well, I3C is already widely deployed in a number of sensors, and so in devices you already have I3C now, and it is widespread. It's different when we talk about I3C in the hardware supporting the eUICC. We start seeing already that there are some commercial chip that already support I3C together with ISO.
Okay. So you, from your point of view, it's already in deployment.
Yeah. I3C as such is already in deployment. You can see different manufacturers that already have secure micros supporting I3C, ISO and I3C.
Okay. Do we have any other questions from the attendants?
So this is Manfred from Infineon. May I ask a question? So thank you, Guido, very much for this presentation. So I'm definitely not an expert in ETSI. I'm more in the ID area, and that's why I'm really interested in what you can tell us about this. May you go please back to page 8, please?
Just give me a second.
In the meantime, I can say also thank you very much, Jean-Daniel, because your question similarly goes into my direction. You say something about the trust model.
Mm-hmm.
The SAM governance is out of GSMA scope, and this is exactly what I actually want to ask. So in the ID area, like this government use case you presented, this is an old story where the governments, but not just governments, also let's say travel agencies or things like that. They want to securely store their data on the mobile phone. And there have been a lot of approaches which embedded secure element, and this is very hard. It turned out to be very hard. You may have heard about the project Optimus 2, where Samsung, Bundesdruckerei, T-Systems tried that. And the central question is, who is actually owning the SAM or the eUICC? If the government is out of GSMA, I would assume it is not anymore owned by the GSMA. Who is the owner of it?
Yeah, so exactly. So it was a very long and interesting debate, as you can imagine, in GSMA. So the point is that, unfortunately, GSMA didn't define an owner of the SAM architecture. It is defined that the SAM CI owner, first of all, there may be more than one. And second, it depends really on what are the authorities that that are selected on a local basis. Third, okay, you are asking me, I think more specifically, who will be the owner of the, well, the final manager of the whole solution. Even this point is not specified. I can assume that in some cases can be the OEM. In other cases, it may be not a commercial entity, or not a private entity, but it may be an administration. But we don't have a specific indication in the technical document. The technical document, the technical discussions we had in GSMA, the decision was to stay neutral, exactly because this looks more like a business decision, and it is inappropriate to define business decision in a technical document.
Okay, so
but thank you very much, because that's a very proper question. Thank you.
Yeah, I will really looking forward to read the Eurosmart paper you have shown. I did not know that yet, but I will definitely read it. Thank you very much for that.
Thank you.
Thank you, Manfred. Do we have any other questions from the attendants? So from what I understood, Guido, you can have different certificate authorities at the same time, managing a security domain?
Yeah.
Okay. Which is it's quite flexible.
Yes, absolutely. It was perceived since the beginning that it is impossible to define one CI or one CA for everything and very diverse use cases. So actually, the decision was to allow for multiple CAs.
And one question, because you have this embedded SIM and you have this embedded secure element. In terms of reach, okay, sometimes you might want to load an applet in the embedded SIM, and sometimes you might want to load in the embedded secure element, depending on the business agreement and everything. Would this applet be portable across the SIM and the secure element, or are there some conflicting standards that would prevent this? Can I write one applet that would be both in the SIM and the embedded secure element?
You can. Of course, you have to keep in mind that that applet has to run in two different environments. I mean, probably the API that you will use in the eUICC will be different from the ones that you will use in the other environment. So if you want to use the same applet, you have to design it for that. But apart from that, there is no constraint. There is no limitation to convey specifically one applet through through the SAM architecture or through the eSIM architecture. Well, of course, when you deploy it through the eSIM architecture, it has to be part of a profile. So you have to discuss with the telecom operator, and the telecom operator has to include it into its profile. But that's more than a technical question, I'd say.
And beyond, just the applet, would the two use the same kind of secure element remote management system, or are there big differences between the two?
The remote management systems are different. The eSIM architecture uses the SMDP pluses. The SAM uses the SAM SM that you can see here. So the deployments are separate.
But my question was, this SAM SM would work with the SAM applets that would be on the secure element or an embedded SIM the same?
No, it will work with the SAM applet that is in the embedded secure element part. It will not work with the eSIM part. The two systems.
Yeah. Okay. Clear. Do we have any other questions from the audience? Okay, so it's almost time. I think a very interesting presentation and very hot topic that we can see, especially in the digital ID context of Europe. I'm sure we will definitely see some going somewhere in this context. You will receive a link to the presentation and the recording. Thank you for attending. And there is a replay, not a replay, but another session this evening. So if you have some colleagues that could not attend, please forward them the link for registering till time. And we also have a bunch of, just one from the series next week. That will be the last of 2022. If you have not done it, please register for next week webinar. And just a reminder that the previous webinars are online if you missed some of them or want to spread the word. With this, thank you, Guido, and thank you everyone for attending, and have a good day or good evening.
Thank you. My pleasure.